Welcome to the Challenge Center. And so if what we're going over today is a little challenging, it is supposed to be. And that's okay because as we learn, hard things help your brain to grow. So we want to challenge and stretch our brain and, work those muscles a little bit so that it grows. All right? So if you have a hard time with this, fine. If you don't have a hard time with this, fine. Okay? But, this is to give yourself a challenge. So we'll see how we do today. What we're going to be talking about today is prime factorization. Prime factorization is breaking down a number into factors. Factors we learned the other day, so we're good there. That are all prime. What we did not learn is prime. However, this shouldn't be a completely new word for you guys. So I'm going to show you over here prime, okay? Prime number, when you multiply, you can only make that number with a factor of 1 in itself. So it sounds complicated, but it's really not. So, for example, yesterday I showed you the factors of 12, right? 1 times 12, 2 times 6, 3 times 4. So 12 has 1, 2, 3, 4, 5, 6 factors. So 12 is not a prime number. A prime number only has 2 factors, 1 and itself. So 12 is not prime. However, a number like 3, what are all the ways I can make 3? 1 times 3. 2 times anything? Nah. 3 times anything? I already have 1 times 3. 4 times anything? No, it's already too big. The only way I can make 3 is 1 times 3. So 3 is a prime number. Okay? 2. Sometimes people think prime numbers are all odd numbers. But that's not always true because 2 is an even number, but 2 is a prime number because the only way you can make 2 is to multiply 1 times 2. So 2 is a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 is a prime number. Now 15 is the next odd number. So a lot of people want to say that 15 is prime. But you can make 15 by doing 1 times 15, but also by doing 3 times 5. So 15 has 4 factors. It is not a prime number. Okay? So now hold on to that knowledge because that knowledge is going to help us with prime factorization. So prime factorization is breaking down a number into factors that are all prime. So since we've been talking about 12, let's start with 12. We're going to start with the number 12 and we're going to break it apart into a pair of factors. And we're going to break it apart into 3 times 4. Now basically when I'm doing prime factorization, I want to break down these numbers until the only numbers I have left are prime numbers. So I have to see if either of these numbers can be split apart again. Well, 4 can be made by doing 2 times 2. 3 could be made by doing 1 times 3, but then that means that 3 is prime. So I get to stop there. That's a prime number. Now, I could split up 2 into 2 times 1, but that doesn't make sense, and I'll keep getting 2's. So 2 is a prime number, so I stop there. So when I'm doing prime factorization, I stop with my prime numbers. Okay? We could do, can you do it a different way and still get the same answer? So for example, 12 is the factors 3 times 2 times 2, because that's what I was left with. 3 times 2 is 6, 6 times 2 is 12. If I go over here, what if I started by doing 2 times 6? 2 is a prime number, so I can stop there. But 6, I can make 6 a different way. 6 is not prime. 6 can be made 2 times 3, but 2 and 3 are prime numbers, so now I'm done. So my prime factors of 12 is 3 times 2 times 2. They're the same ones I got over here. Okay, so it doesn't matter which way you break apart a number. When you get to the end, you will always have the same prime factors. Let me do one more for you. And what you can do is I'm going to write the number on the board. And I would like you to pause the video for a second and see if you can figure out the prime factors on your own. Then go ahead and start playing it and see if you got the same prime factors as I did. Remember, there could be more than one way to get there. We just want to see if we end up with the same prime numbers at the end. So I'm going to start by doing, I don't know, let's do 6 times 4. Why not? 6 times 4. 6 can be broken up into 2 times 3, so 6 is not prime. But 2 and 3 are prime, so I'm going to stop there. 4 is not prime. It can be broken up into 2 times 2. So 2 times 2 are prime. So now I have all prime numbers, so I'm done. So my prime factors of 24 are 2 times 3 times 2 times 3. And remember, with the commutative property, we could rearrange them. We could put all the 2's. We could do 2 times 2 times 3 times 3, and it's still going to equal the same thing. So go ahead to your challenge center in your classwork section and try some of the problems for prime factorization. Good luck.